Okay, this is my second talk. I don't know if you've seen the first one, but in the second one, I will once again use my own tool at some point, and if it crashes, that's because I coded until the last minute before flying to SharkFest. But first of all, of course, there will be some slides, and this is what we're going to look at. Once again, there's a little haystack. If you're doing network forensics, that usually means that you're looking at a lot of packets very often, unless somebody already filtered stuff for you. But very often that's not the case, so you get tons and tons of PCAPs, and they're like, you know how to do this, take a look at this. I will take a look at Snort and Suricata. I don't know if you know either of them, one of them or both. Basically, they're open source IDS systems that we can use to do pattern matching for us, or try to search for things that you want not to filter on manually, because of course you could run Wireshark on tons of trace files and look for patterns with display filters one by one, but that would take way too long. So the better way is to have a tool like Snort or Suricata automatically scan through your PCAPs, find all the interesting things, and then look at them. TraceWrangler is somewhat helping me here, because you will see how tedious it can be to do all the verification of hits by hand. That is something I've done in the past, sometimes taking days or weeks even. That is where being a network analyst is not that funny anymore, because you're constantly refiltering, and still finding nothing, because otherwise you could say, well, let's investigate this one. But I had a case where I was basically filtering for a week on TCP conversations, one by one, hundreds of them, just to check if there's something malicious in there or not. And that is a bit of a not so fun experience, which is why I taught TraceWrangler how to do that for me. Well, basically not the final verification thing, but the parsing stuff out of greater PCAPs thing. Question?
Is that normal to do that for a whole week? I mean, that's a normal experience for you? Or?
It's not a normal experience for me, because first of all, to do this, you need an incident, which means something seriously must have or something serious must have happened to your network, so that someone tells me, okay, investigate this, please. Because if somebody tells me to investigate something, he has to pay for this. And since I'm working for Airbus, that rate is not exactly, well, let's say you need to be serious about that you want me to look into this. Okay, so yeah, you need an incident. And that is something you don't want, because nobody wants incidents. Incident means somebody broke into your network and it needs an investigation. So there's not so many incidents that you actually work on, because sometimes incidents are kept under the rug or swept under the rug. Like, okay, it happened, clean up the systems and be done with it. So it must be serious enough for someone to actually do network forensics. And in the end, of course, Wireshark, because that is the tool that tells you exactly what you can see in the packets, and that is what you need to use to finally say, okay, this is a malicious conversation or a TCP connection or not. Okay? Good. So the incident haystack, the problem usually is that to have an incident, it doesn't appear out of thin air. Basically what happens is that somebody says, well, I found something odd here. Then he investigates a bit, and then he realizes, oh, this is serious. Let's say I had a case like a few years ago where somebody found a file where he said, well, this is nothing I've usually seen on this server. What is it? And he was looking at it and realized, well, it contained like a command history of keystrokes. Like all the keystrokes that had been done on the systems were in that file. And he realized, well, some of the commands were what I've done on that system, but I didn't record them. So he realized it was some kind of keylogger. And as soon as that happens on systems that are important enough, you basically have no choice than starting an incident response process. Basically meaning let's investigate how that could happen, where the software came from that did the recording, what software it was in the first place, and what else or what other systems were infected. So you need something kicking off the investigation first. Yeah, because otherwise everybody's like, hey, we're safe, nothing's happening, everything's cool. Nobody will open an incident response case just for the fun of it. Even though there's this saying, I don't know if you've heard it, but we tell it all the time, there's the companies that know that they've been hacked, and there's the companies that don't know that they've been hacked. There is nothing else. Yeah, so my usually way of doing things is either I'm investigating incidents, that is when somebody realizes that he has been hacked, or I should be looking for signs of somebody hacking the systems. Because most likely something like that is going on, unless you're the totally unimportant company. Yeah, because the Chinese, the Russians, the French, the Germans, the UK guys, everybody is probably interested in what everybody else is doing, so all of them are trying to find stuff. Okay, but usually for an incident to happen, as I said, you need something that kicks it off. And then you need to check a lot of things. Clients, servers, networks, meaning like, is this router been compromised? Stuff like this, even that can happen. And of course, the uplinks are a very interesting source of information, because if somebody is in your system, he's usually doing that from the outside world somehow, remoting into your network infrastructure. So you should be able to see that on your uplinks. Yeah, and that is something that we very often do. We want to have a full packet capture of the internet connections, all internet connections. And that can be a challenge. And I told you about the 4 terabyte trace we had to look through. This can happen quite quickly if you're running a capture for let's say a week or something, capturing everything that is done in the company. And if you have a gigabit link, you fill that up quite easily. So a terabyte is nothing in that regard. So the problem is, I don't know if you know this, but there's people who do system forensics. Basically what they do is they make a copy of the hard drive, and then they use forensic tools to build a timeline of who has done what on this system. Like who has deleted a file, who has issued a command, who has sent an email. All that kind of stuff is system forensics. Basically meaning somebody removing a hard drive, making a copy with a write blocker so that he doesn't write stuff back to the original, put that in a safe, then make another copy of the copy, put the copy in the safe too, and then work on the third copy, because then you have a chain of custody where you can go back. But the problem with this is the copying of the drives takes a long time, and you need a specialist to do this. And if somebody tells you, well, we have an indicator of compromise, like a keylogger found somewhere, and we have 500 servers, please investigate. You will need a lot of investigators, because this takes a long time. So if you're going through a system manually by hand with a skilled forensics investigator, you can calculate at least a couple of days per system. So if you have hundreds of servers, there's not enough forensic analysts in the world to do that for you, probably. So what we always do is, well, what systems are important enough for a system forensic guy to take a look at? And what we usually say is that you can tell by the network patterns of the system if it's infected or not, or you should be, or very often you can. So we're looking at the network data to pinpoint the systems that need further investigation. Okay, that's the idea, looking at network data to find things that need investigating and not go through hundreds of systems by one, because that's usually not necessary. So how do we do that? Yeah, well, the system guys are looking at file systems. Everybody's looking at log files, firewall rule tables, which is very interesting. I don't know if you ever looked at firewall rule tables that have grown over a couple of years. And then you start asking questions like, why is this rule in there? Good luck with finding someone who can answer that, because very often it's like, yeah, we don't know, something a couple of years ago, it's still in there, and yeah, very often there's a grown architecture of firewall rules, and basically companies are very often opening up their networks more and more for various reasons. And there's always this famous, I need an any-to-any rule, please. It happens. And analyzing that is also something of a problem. Then we have sensor hits, IDS, IPS. Does everybody know what that is? Intrusion detection system. And an IPS is an intrusion detection system with automatic blocking. Who is running an IPS system? Okay, who is running an IPS system which actually does blocking? Okay, 2. That is more than usually happens. All the companies I know are running IPS systems, but they don't dare to activate blocking. Because the normal applications may be blocked for whatever reason they think, so they don't dare to activate blocking. So most IPS systems that are sold are basically either not even run inline, which is required to be able to block packets, or they are inline, but nobody dares to activate the blocking features. I've sometimes enabled blocking features on my own because I was certain that this kind of thing couldn't be a false positive. But IDS, IPS, and NSM is a general term, network security monitoring device, which is something like a head topic for IDS, IPS. They are not the final solution because they can be circumvented or passed by if you know what you're doing. You have to remember the bad guys are probably having enough money to buy every box that you own and test their stuff until they find a way past it without it realizing. Yeah, so you always have to assume that all your hardware is good for basically just the common criminal, but not if somebody with a unlimited amount of money like a state agency is targeting you. Then all of this is nice to have, and you get a check mark at your next PCI report if you're payment card industry related, because they require you to have one of those. But it's not good to catch anything. And I had one customer call me last week or the week before, and they wanted from me a percentage by which their risk was reduced if they introduced IPS. And they were like, is it more like 70 or 80%? Yeah, well, if I have a good day and I'm giving your IDS, IPS the benefit of the doubt and telling you that it's catching everything that is coming through, maybe 20% is more realistic, but that is a high number, actually, because the real good stuff you won't see in an IDS, IPS system. Yeah? Okay, and also, does anybody know what the other difference between IDS and IPS is, except for the blocking thing? The IDS has way more filters. So the IDS has something like 50,000 different patterns to look for, and the IPS only has 7 to maybe 20,000. And the reason for that is simple. The IDS knows that it doesn't block anything ever. So they have patterns that consist sometimes of only 2 bytes. Like if I see those 2 bytes, it's a match for this. You cannot afford that if you are blocking based on this. So your patterns need to be longer and very, very precise. And precise patterns take time to create. So IPS systems usually have a lot less of filters and signatures and patterns than the IDSs do. Yeah? This is a big difference between the two. AV, antivirus. AV is, well, helping somewhat, but only against known stuff. So it will not find anything that is brand new, ever. And then sandboxes. I don't know if that is a term that you know. Basically, FireEye and those things are sitting inline again. If they see an attachment or something being pulled from the web, they put it into a virtual machine, run it, check if it does something malicious, and if it does, it gets blocked or otherwise flagged. So that is the latest stuff that you are supposed to be running in your company. So sandboxes, well, actually try to run software and check it out. And even those things can be bypassed more or less easily. I never said that. Documentation, very important, because if you don't have documentation about how your network runs and what applications you have and then which ports they are, it gets really complicated finding the bad stuff, because if you're wondering, is that communication on port 445 normal? And nobody can tell you, then it gets quite complicated, because finding an infected box where somebody opened up a TCP port that shouldn't be there, well, you need to be able to match it against the baseline saying, this shouldn't be there. This is strange. Yeah? So documentation is very important. And unfortunately, documentation is almost always something between non-existent and outdated when it comes to company networks. So, as I said, network forensics is the one approach that we use to pinpoint systems that need to be analyzed further. And one key point here is that no matter how good the malware is, even if it can bypass every IDS, IPS, antivirus, whatever, the final goal of these guys is always to extract information. How do they do that? Well, they basically are using your network infrastructure. They're using your internet uplinks. And they're hiding in the data stream. And your task, or mine usually, is to find them. And that can get really tricky. I have some examples that are so hard to spot that you will never find them, no matter what you do. But if you get the normal things like Zeus infection or ransomware or Locky or whatever it is, they are quite chatty and you can find them. And I will show some examples how you can do that. Not all of them may work still because they're a bit older now. But the principle is the same. If you do a good capture at a location where they need to come through with their packets, it's only a matter of if you can spot them. And that is a matter of how good they are hiding. Okay, the problem is, of course, sniffing packets at the right spot and having gazillions of packets that you need to look at. So, for a little food for thoughts, this is a fun thing that I found a couple of weeks ago. You don't need to be able to read code, but I found this code example, and it has subroutines called anti, and that is anti-forensics. So somebody wrote a malware and put code in to fight against forensic detection or detection in general. So what they're doing in this one is they are using a timer to check how long it takes to sleep for 500 milliseconds or microseconds, whatever the value is. And if they wake up again and after the sleep is done, they check, did I sleep for that long or much longer? And the trick is if somebody is stepping through your code by hand and putting breakpoints and stopping your execution because he's analyzing what you're doing, that will be taking much longer than it will normally do. Or if you're in a sandbox and the sandbox is slowing you down, also the time will be much longer than what you expected. So that is a way of detecting if you're being investigated. But the more important thing here is this one. Here he's calling fverpreciso wireshark.exe, xns5.exe, Wireshark with a lowercase w, and with an uppercase S and other Process Explorer, for example. If you see a list like this, this is anti-forensics. So somebody's trying to hide, basically. And what is happening here, there is a for loop looking for Windows 32 processes with those names, and if any of them is found, then end. Basically means the malware will not do anything bad when it realizes that somebody is monitoring it with Wireshark or other tools. And if you take a really good look, the programmer even was doing something that wasn't necessary, because you can see Wireshark, Wireshark, Wireshark 3 times in different ways to write it. But here he's doing an uppercase on the names, so everything is in uppercase. So he's comparing uppercase Wireshark 3 times, which is kind of useless. So you could remove 2 of them here. But
if you're using a tab, that's not important.
If you're using a tab?
That's not important.
No, this is not. That has nothing to do with the tab. This is a malicious VBS script. Yeah. Yeah. So if Wireshark is running on the computer that is about to be infected by the infected document, it will check if Wireshark is running and then not do anything to not be detected. Basically being like, I do nothing. Yeah. So this is quite common. So how did I find this one? Actually, what I did is I have a Pastebin account, a professional one, because then you can do alerts. And I put a keyword alert on the name Wireshark, and you can see I was alerted 107 times that somebody pasted something on Pastebin with the name Wireshark in there. And sometimes you find code examples like this. Very often they just post something like their Debian setup script, how to install Wireshark and stuff like this. But this is a fun thing to find stuff that may be interesting. Now, I have other keywords that I blocked out because I don't want them on this camera. Okay. All right, so this is what people do. They try to fight you, and if you are thinking about, well, I just put Wireshark on the server to find the malicious packets, no, you don't, because they may expect that, okay? This is not a single example. It happens a lot of times. So the capture spot is never on the infected system, never, ever. And also, the server administrator will basically not allow you to install Wireshark on his system just for the fun of it. Yeah, so, yeah. Okay, span ports are okay-ish. Yeah, you can use them. And I had to use them a couple of times because very often if you're in an incident response situation, time is really short and you cannot just go into a data center and start unplugging cables just for the fun of it. But what you can do very often is have a span port configured and just put any PC in there and capture the packets from the server. I've done that a couple of times and it works okay. It's not totally undetectable, maybe, because the bad guys may also have already access to your switches and they can check the switch configuration. I've never seen that before actually happening, but it is possible. So whatever I do on my network to capture packets and that is accessible for anybody who has access to the network, and the bad guys do if I'm looking for them, that may not be a good idea. So using a tab is recommended because if you put a tab into a network link, you will have a link down and a link up, of course, but nobody can tell if that was for inserting a tab or something. And if you insert a tab way ahead of time, for example, at your internet uplinks, you will have full access to all data and it's completely undetectable for any attacker. He just cannot know that you're recording everything you're doing. And if you want a fine example of that, you can read the Chakuz egg, or how it's called, from Clifford Stoll. He was basically doing that with line printers back in the day when he was on some very slow links. That is basically the first wiretap we ever had, I think. Okay, so what we recommend is look at internet links. And I always try companies who are afraid of something happening to the network to tap all their internet connections and have boxes there recording 24/7. So that whenever something happens, you can go back in time and look at it, because network forensics is impossible without a capture. And a capture cannot be done back in time. So if you don't have it, you don't have it. Okay? So the most important thing is to start thinking about this thing. And of course, you don't want to put capture devices all over your network because it's way too big, but you probably have only a couple of internet uplinks and can tap them quite easily and just record what's happening there. There's some issues with worker rights and stuff like this that needs to be sorted out, but my recommendation is always go get there and at least capture all the SYN packets, FIN packets, reset packets, SYN-ACK packets, and DNS. You don't need the content. You can just capture those packets to see was a connection established or not, because very often you're interested in, well, did this attack work? Well, if the attack worked, usually what happens, the infected machine opens a back channel, so it's sending a SYN connect out to the command and control server. And if you see that SYN on your capture and you see a SYN-ACK coming back and then an ACK again, you know, okay, there really was a connection established from my device to the malicious side, and then I'm in trouble. Then I need system forensics on that system. Yeah, so what we do is capture just SYN, SYN-ACK, FIN, reset, and DNS. And DNS is very important. Whenever somebody tells you in network forensics, forget about DNS, leave the room, okay? Because DNS is the most important thing ever. And I will give you a couple of samples why.
tap is between your internet links and a firewall where you're NATing, and then you don't have the actual client IP address?
Yeah. The question was, what about a firewall that does the NAT thing? Where do I place my tap? That is actually a very important question, because if you put the tap on the inside, you can see your internal IPs, hopefully. But depending on what is happening on the outside, you may not see where it's going, actually. Yeah, so we sometimes have things like somebody connecting a proxy, and if you put the tap between the proxy and the client, you will not see the connection from the proxy to the outside world. So you need to really think about this and find out, okay, where do I see all the information that I need? I usually recommend to not put the tap on the outside of the firewall. So in front of your firewall, it will see lots of useless scans coming from all over the world. So you're having stuff in there that you don't really care about. I usually put them right on the inside of the firewall. So if this is the internet and here's my firewall, the tap will go here. And then there's the rest. Yeah, so that is usually the best spot. And it may mean that you need a lot of taps, because there may be redundant links, so every link needs a tap, or you need a tap that can tap both, or a packet broker or something like this. If you have more than one internet uplinks, you need to tap every of them, every single one. And, well, if you have some other things like this, I don't know if it's called DSL around here, but in Germany I have one customer who has 100 DSL uplinks for special purpose networks that are not supposed to be connected to the company network. But can you be sure that they aren't? Somebody will maybe put a device into the network that is connected to both, the inside and the DSL network, and now you have a bridge maybe, and then you're in trouble again. So very often you need to take a look at even the DSL networks, which is a pain in the whatever, because you need to track them down first. Yeah, so it can be a challenge, but usually to find the main internet connections is not that problematic. Then the undocumented ones, if that happens, somebody did not do his job, so documentation needs to be updated. I had one network analysis job where I was supposed to capture the server and they didn't know where it was. And that is always funny, because you're spending half a day finding the server first. Yeah? And then we sold them like 2 days of network documentation from one of our assistant people, just crawling through spaces and writing down cables and everything for the next time. And then there's rogue uplinks. Well, rogue uplinks are those who are not authorized at all, and those happen too. I've seen companies where persons working for the company ordered a DSL uplink that wasn't authorized, and of course it wasn't documented, and of course he would deny that there's this one uplink, but it was hidden under his desk basically, and he hoped that it wouldn't be found. Yeah, so that can happen too. Okay, so now to DNS traffic. I don't know if you ever heard about something called passive DNS. That is basically a database with a sniffer, and it records everything that you do on the DNS. So it will allow you to go back in time and say, well, 20 days ago, to what IP did this domain resolve? Because malicious domains very often change IP addresses, and if you need to know where did it point to at what time, passive DNS is the way to go. So passive DNS is basically nothing else than a MySQL database with a sniffing process writing data into it. And then you're responsible to create SQL queries to pull the data out again. Yeah? A friend of mine working for a government institution basically does stuff like, okay, what IP address is having the most domain not found answers coming in? Yeah? So he's building a top list of who's getting the most failed DNS requests, because domains that are registered by malware very often disappear after a short amount of time, so you get a not found answer back. So if a system is getting a lot of not found answers back, there's a question, what is happening? Because either somebody's typing in domains all the time that do not exist, which is highly unlikely, or there's an automatic process that is doing something wrong, which would be something that you need to fix, or there's malware running trying to connect to the control servers outside that do not exist anymore, and that way you can spot them. So they're using passive DNS for something like this. And the other thing that you can find is answers containing loopback addresses. Why is that interesting? Loopback addresses. So you're saying, well, domain something.com, and you get back 127.0.0.1. There's two reasons for this. One is a legitimate reason, which means it's not always a bad thing. And the legitimate reason is, I think, something that Christian talked about yesterday. You have a spam feature where you can ask blacklists if a domain is malicious or sending spam, and it will ask for the domain name before accepting an email. And if 127.0.0.1 comes back, it's okay. Yeah, so that is a good way. So what I do is, if I see loopback addresses, I always need a list of what are your mail servers, because if it's a mail server getting that answer, okay, yeah, fine, probably. Yeah, maybe the mail server is infected, so that then it gets complicated. But other than that, if you have an attacker who is, well, a working person very often, so they eat and sleep and sometimes are not in the office and maintaining their command and control servers, so when they're not working, they very often point their malicious domain names to 127.0.0.1, which will lead to, if an infected system is trying to connect to the outside world, finding the control server, it gets an answer like, okay, talk to yourself, which means there will be no communication coming out of it, because talking to itself will keep all the packets on the inside. And as soon as the guy is back to work, he will change his configuration of the DNS and toggle it to a valid IP address. And then the client, the next time when it asks, like, where's my control server, it will get the real IP and start the communication. That way, by using DNS, an attacker can control if there will be TCP or not leaving your network. So very often we look for stuff like loopback addresses or other answers that basically point to himself. Like if you get a private IP address back from the outside, that shouldn't happen either. Or if you get like broadcast back, that shouldn't happen either. So there may be misconfiguration, but sometimes it's a bad thing. High amount of no such name, I already said. And then there's the domain generation algorithm. Who has seen domain name generation algorithm results? Jin has, but he's a network forensics guy. Who else? You do? Yeah, of course. I'll show you an example. And it's a funny example because it's on my desktop. That's not why it's funny, but no. Basically, this is an infection, and the malware is trying to communicate to the outside, and the antivirus didn't find it because otherwise this executable doing that would not be alive anymore to do this. So if we go and filter on DNS real quick, can you see this from the back? I can also turn off the color for once. Is there anything that looks kind of odd? Huh? No, that's not Chrome. Oh, maybe it is Chrome. Yeah, good idea. Because Chrome is doing something similar, because I think all of you have by now seen which domain I mean. That one? Sometimes Chrome is testing if there's something going on in the network that shouldn't be, so it's using generated domains too. But this looks not like the ones Chrome is using, which is kind of an experience thing again. So if I see this, I'm like, uh-oh, this doesn't look too good. But if we looked through all the packets here, we have a couple of them. And now the big question comes up. How do we find all of those malicious queries? I can tell you it's not easy because they are random, more or less. Sometimes more, sometimes less. There are some generation algorithms that basically concatenate words from a dictionary so that they don't look as suspicious as this one. Funny enough, for this example, we have figured out a way how to find most of the communication here. Huh? Which one? No, I don't think so. Maybe you can just filter for the .biz, but it doesn't help because very often they're .com and then you're out of luck. So what we did here is like DNS query.name contains Q. just the letter Q. Because the letter Q very often, or very rarely, appears in normal domain names. It's a very rare character for this. So if you filter on that, you can see that the results are mostly strange looking, right? So that would be something that works in this trace, but let me tell you, that doesn't always work, because otherwise it would be too easy. The coders who write those generation algorithms, because they need to swap domains all the time, are, of course, also always changing their algorithm, and it gets harder and harder to find them. What we can do here now is something interesting, which is why I said this is funny. There is a website in Germany from a German institution that is called the DGA archive. And what these guys do is they take binaries, malicious binaries, pull them apart, analyze the generation algorithm, and build a database. When I post something in here, they will look in their database and tell me which malware it is, based on the pattern that they found in my domain name. So let's try this one. I go into my trace file. I pick the first thing here. By the way, you can see that there is an answer IP, 67 to 15 and so on. So this is a live server. So now I could be looking for a TCP connection actually going to this one, if it would be here. But now let's check if this is in the database. So I go down to the query. And here's the query name. I say copy value. Then I move over to the website. I paste this thing. And I say perform lookup. And now I can see that is Game Over Zeus peer-to-peer. So now I know which kind of malware it is. And that basically helps me pinpointing the executable and maybe talking to my antivirus vendor why he doesn't find this kind of thing in my networks and stuff like this. So this is really helpful sometimes. But this website requires a registration, and I'm not sure if they're giving it away to people they don't know. I got one, but I know these guys. So you can try, but I'm not sure if they will let you in. I think when you pull it up for the first time, it will tell you something like there's registration required. Let me check. I probably have to close my browser to lose the session first. DJ. Yeah, it says here, to request access, write an email to this guy. So if you want to try, maybe he will let you in. What usually helps is if you're from a law enforcement agency or government, then it's usually easier. If not, it may be that he says no, because he wants to avoid that people writing malware get access to this, which is understandable, right? So if they refuse you, don't be mad at them. It's just that they're protective of what they're doing.
Jasper, is domain registration automated? Can't the registrars prevent people registering these weird names?
Yeah, domain registration is pretty much automated. I mean, if you're going to GoDaddy in something like this and you fill in forms and stuff like that, that is a manual process. But all of the registrars have APIs that you can connect to and just register stuff like crazy. And as far as I know, you can even register some domains free of charge for a number of days. So what they do is they register them and drop them instantly after using them for a day or two, which is why they're hopping so fast. And that is why those algorithms need to be reverse engineered to find out where they will be going in the future. And then you can go ahead and try to find them before they actually do that. Okay, so that was fun.
Did you have a question?
Yeah.
Could you tell me what passive DNS is?
Yeah, passive DNS is a project by another German guy, I think. If you Google for that, you will probably find it. It's a tool that you can install on a Linux server and run it to capture DNS packets for a historical search basically. So I think I'm going for DNS. Oh, wait a minute. Passive DNS. I think it's this one. Game Linux, which sounds a bit funny. Yeah. A network sniffer that logs all DNS server replies for use in a passive DNS setup. Yeah. It's on GitHub. You can get it, install it on your Linux machine and run it and fill up the database, basically. Yeah. The more room you have, the more you can go back in time.
Is this something you're directing CAP or span packets
Yeah.
to?
Yeah, exactly. It's basically nothing like it's a PC with a sniffing card where you accept packets coming in from a tab or a span port, and it just basically takes all the DNS packets and writes the answers to a database. So it's a very special sniffer, like the kids do for passwords, or used to, because now it's all HTTPS, right? Yeah. Okay. Well, then there's the other thing called NetFlow. Who's using NetFlow? Okay. Who's not using NetFlow? Some of the rest. The others don't know. NetFlow is something that I usually recommend because there's very often this question like, okay, we know this server has been infected. And that was like 5 weeks ago. Where did the attacker move from that server? And I'm like, do you have NetFlow? Because then I could tell you from the meta information that you recorded what kind of connection this system did at that time. Very often we don't have it, so that means I can't tell you. Then the system forensics guys had to go in and do the long kind of thing with copying the hard drive and all that stuff and try to find if somebody did something on the system that can tell you that it moved somewhere. But with a NetFlow installation running and capturing and recording all the movements in your network, that would be easy. And for troubleshooting purposes, NetFlow is a good idea anyway. Yeah, of course, it's expensive because very often you cannot run it on the switches and routers you have because the samples, if you're collecting those samples, the CPU is going and basically dying on you unless you have a sample set of 10,000 samples per or one sample per 10,000 packets, which doesn't make any sense for stuff like this. So you need extra probe boxes that collect this stuff. So there's cost involved, of course. Yeah, but NetFlow is a very good idea because it will keep information about who did a connection to whom at what point with how much data. And I can only recommend doing that, especially for important systems. You don't need to do that for your user networks, but the server segments should all be NetFlow monitored, because then you know who's talking to whom, and very often you can spot malicious activity by just saying, why is that web server talking to that other server? It doesn't have any reason to do this. And then you can investigate. Without NetFlow, you can't do it. Well, you can. You need to capture packets and look at them, but that's much more data and much more time-consuming than using NetFlow. So I always recommend using that. Baselining suspicious systems. If you have a suspicion about a system, go in, tap it, record everything it does, and then if you think that you found something that tells you this is really an infected system, hand it over to the system forensics guys, because then you're done. You can't do much more than that. Okay? And that is not saying something about how hard it is to actually pull down a server for an inspection or a forensics investigation, because the administrators and management will fight you tooth and nail for you not to take down a production server. Okay, so that is very, very hard to do in some situations. Okay, now verifying indicator of compromise hits. That's what we're here for. First of all, we need to generate hits. So you need indicators of compromise. Yeah? Very often, if a network forensics search is running, I already have a set of things to look for. And those come from whatever source, very often from system forensic guys that tell me, I found this binary on that system and it uses a specific kind of way to communicate, and then we build a filter for Snort to check if there's any network communication using that pattern. One of the things I've used or seen is a copyright string from a C library that the attackers used in their program and that you can see on the network. The problem with that is that C library wasn't just used by the attacker, but also by programs used normally in that company. And that should tell you something about verification, because now I need to go in and check every single hit to see, is that the normal program or is that the bad program? Yeah, and that's what I'm going to show you. So steps involved are simple. Capture the traffic. Without traffic, we can go home. Then run Snort against the PCAPs. If you don't know Snort, it's an IDS system, an open source IDS system, basically the foundation of SourceFire, which has been acquired by Cisco. So now you find that stuff in their ASA devices, I think, Firepower or whatever it's called. Snort is, well, open source, so you can download it, run it against your PCAPs. Then grab the results. If it tells you there's something I found, you need to verify it. And that's what you're going to do in the originals, because why do I have to go back to the original files? Who has ever done verification of IDS hits in here? You? Okay, just one. I can tell you a story about this. I have a customer where I regularly appear to help them with classifying those kinds of incidents because they have an IDS running and they want to know, is this something we need to look at or is this nothing? So basically doing false positive from true positive separation work. And there was one alert coming up where the IDS said, oh, I have shellcode in a transfer. And if you don't know this, shellcode means somebody is using exploitable stuff to gain access to your system. So seeing shellcode is bad. Yeah, this is something you always need to take a look at. So I was looking at this and I said, well, do you have the packet that triggered this? Yeah, we have it. Here's the packet. And I'm looking at the packet and saying, yeah, well, there's the pattern that is an indicator of something bad going on. But it was just a hex pattern without any context. So I knew the IP addresses, of course. I knew the port numbers. It was two IP addresses, one internal, one external. The port numbers internal was a ephemeral port. The external port number was port 80. Good luck with that. And the pattern in the hex was not decoded at all because it couldn't be decoded. It was just some bytes. I was like, okay, and that happens to you if you are used to IDSs. They always give you the one packet where the pattern matched, nothing else, just the one packet. And you're like, I don't know, maybe it's good, maybe it's bad, I don't know, I need more context. I need to know, I mean, this looks like it's web traffic, but where's the GET request? If I see the GET request, I can tell which domain name it's going to. Maybe I can even tell if it's some binary being downloaded from a trusted site. I always need the GET request, but I didn't have it. So going back to the original PCAPs, you need to look for the conversation of that single packet. Yeah, so you have the packet, you find the conversation to that packet, and then you can take a look at everything. And in this case, what happened was there was a capture set of, I think, 100 PCAPs of maybe 200 megabytes each. And I started going backwards from the point in time where the hit was found, opening each PCAP backwards to find the GET request for that conversation. And it took half an hour to get to the first file because the hit was in the afternoon and the GET request for that TCP connection was at 6 in the morning. And when I saw the GET request, I knew instantly this is not a bad thing because it was a GET request for a web radio station. And if you're listening to music, every once in a while malicious patterns will show up just because the music in the stream is looking like malicious traffic. But going back in time to find the GET request, opening PCAP after PCAP, going backwards, takes forever. And I was going crazy because I just wanted to have the GET request, not looking at, well, just opening the PCAPs takes time. And it was a remote connect, so it was slow. And you can feel my pain, I think. Yeah. It wasn't fun, and that happens every once in a while. Every single time one of the guys in that office listens to music over web radio, at one point in time this hit will come up, and then we will have to find that damn GET request. Every single time, and very often it's in the afternoon and we have to find it in the morning. But if you start in the morning, you can be sure that you just started it in the PCAP before the one you're looking at. So it's Murphy's Law. You will never find it right away. You will always find it after a long search. So that is something that we're going to do not manually anymore, but using TraceWrangler. And I want to show you the whole process from the beginning to the end, okay? Not totally from the beginning because I'm not going to capture packets here. I brought some, but the rest will be there. So I'm not using my normal command line, which is this one here, because you can't read it, it's too small. I'm using the normal Windows one. That should be better. Okay, so I go to my traces folder. And you can see here I have 2 PCAP files, snort, capture 1 and 2. Usually you have like hundreds of them. But for the sake of not having this run forever, I just use 2. And I have a script that is called processdir.cmd. I'm a fan of having batch scripts with all the commands that I usually do. And I'm going to show you what's in there. This is what it does. I have a local snort installation. It calls snort.exe. It tells Snort to read all the file from a file called pcaplist.txt, which I don't have yet. You haven't seen it in the directory because it's not there yet. pcapshow is basically just a debug command telling me which file it's currently working on, so that I can tell how long will it take. And there's a config file here where all the patterns are found. So in that fnhlocal.conf are all the signatures that Snort should look for. And -L just tells it to put all the results in the local directory so that they end up there. At least I think that's what it does. So now I'm going to show you the fnhlocal.conf file, if I can find it. It's in the C directory, snort, etc, fnhlocal.conf. And the beginning is not important, but in the end you will see there's includes. This doesn't look right. Maybe it will reference another set. Where's the big one? Or maybe I stripped it down. I'm not sure. Normally you have all the rules in here. Interesting. Should be this one. Not sure where they are, but I think they work. They should work at least. Normally, of course, there is more stuff in there, but I think maybe I moved some for the last demo I did because if it matches everything, it's too much in the end again. Okay, anyway, now I need to create this list of PCAPs that Snort should work on. So what I do is I dir/b, and if you've ever done that, you know that this will just give me every file in the directory, but without the path. If I omit the B, you will get everything. I just want the file names, and I put that into pcaplist.txt. I think that's what it was called. So now I should have a new pcaplist.txt file. This can go away. but there's a little bit too much in there because there's also the pcaplist.txt and the process_dir command in there. So I edit it to remove everything that is not a pcap file. So now it should work. Let's check the command again. pcaplist.txt was the right command. And now I can run my process command, because that means Snort knows, okay, what files should I look at, where's my config file, everything. So now it fires away, or starts. And now we have a little time to watch it do its job. At some point it should tell us I'm working on the file now, on the first one. Yeah, it's a piggy. There's also a program that pulls down the new rule sets every once in a while. Do you know how it's called? Pulled pork. I'm not making this up. It's called pulled pork. By the way, if you want to play with a real-life IDS system without all the hassle of setting all the stuff up yourself, I can recommend a distribution called Security Onion. I don't know if you've ever heard it, but it's a bootable Ubuntu Linux system with all this stuff pre-configured. You just run a setup. It will ask you which is your capture card, what kind of things do you want me to do, and you have a system, an IDS system running in no time, like basically half an hour if you know what you're doing.
What was the name of it? Security what?
Security Onion. They even have a conference now, these guys. And I have customers who do not want to spend a lot of money on commercial IPS systems, so what they do is for all the DSL connections, they just put a Security Onion box there. You can put up a master-slave configuration where one is the master and everybody else is a slave, and you can push rules to all of them via SSH connection, so it's quite a nice system. Yeah, so if you want to go there, Security Onion is the thing to do.
I should put it in my house.
Yeah, you could protect your house with it. Okay, Snort is done. I hope it did everything. Yeah, so we got results. And as you can see, maybe we got 2 new files, one per source file. These are, if I take a look at them with a hex editor, pcap files, right? How can I tell that this is a pcap file? Jim can probably answer that. D4, C3, B2, A1. That's the magic bytes for a pcap file. If that would be pcapng, it would be 0A, 0D, 0D, 0A. Yeah? You learn that kind of stuff if you're writing a network analyzer like TraceWrangler, yeah? Because yeah, you're debugging a lot in a hex editor if you do that. So we know it's a pcap file, so we can open it in Wireshark. But since I'm using Windows and not Linux, Linux would look at the magic bytes and automatically open the correct program. Here on Windows, Windows is confused if there's not the correct file extension. So what I do is I open Wireshark manually, and then I drag and drop the log on there. So you can see, yeah, it's a pcap file. And as you can also see, every hit is just a single packet. So I don't get conversations and stuff. I just get the single packets for all the hits, which is the annoying part, as I already told you. Yeah, so now I need to find all the conversation and find out, for example, if you see the 403 forbidden, yeah, what was he trying to access? Forbidden can happen for many reasons, but I need to find out, is that a problem or not? So how do I do that? Well, I will show you now what I did before TraceWrangler, and that was basically this. I know that each of the result files matches one of the originals, so I don't have to open all of them, at least not in the beginning. So if I want to know what, for example, yeah, let's just take the forbidden thing here. This is, I can go and do a conversation filter, TCP. Oh, it's all the same connection. All right, so that makes it easier because I have many hits on the same connection, so checking that one is going to be a single original conversation for all the hits. So now I open up the original file, which is the first one, I think. And I copied the filter. Now I paste the filter. I have to wait until it loads. This is what drives you crazy in the end. And then filter is pasted, apply it, it's rescanning. You can see in the bottom. And now I have my full conversation here. And there should be 4 or 3 messages at some point. If I enable my colors again, it will be easier to see. Where are they? Ah, there they are. Yeah, so now I can go in here and check, well, where was he going? christiancup.de, something forbidden. Yeah, okay, somebody from the outside trying to access something that wasn't allowed. Okay, not a problem. Yeah, maybe a problem because there should be a web application firewall put before this, so this doesn't happen that much, but this is not a problem. So you do this for every packet in the results file. Okay? And you can imagine that this will be something where you can spend weeks on, just opening all the packet captures again and again, just to find out what it is. So now, that would have been the normal process. And I don't know if any of you have ever done that before, but I've lost weeks and months on this of my lifetime. So what I'm doing now is I'm running TraceWrangler, which once again is a program I wrote starting with an anonymization feature, but now it can do much more. So what I do now is, first of all, add both of the original files to the file list. That will lead to TraceWrangler scanning the file. And what it does is it counts all the addresses, all the conversations. So TraceWrangler will know which conversation is in which file. And now I will do a extraction task because I want all these conversations one by one in single files so that I can easily check them. So I extract. And what I can do now is add filters by hand, but I don't do this. I add filter from a file. So import from file. I select this SnotLog result file with the single packets in there. And as soon as I do this, TraceWrangler will show me, okay, do you want to ignore SYN packets? Because very often you have snort hits on somebody scanning your IPs with SYN packets and nothing happens. So if you want to save some time, you can just say, hey, ignore the SYN packets because a filter match on a SYN packet, nothing has happened yet except somebody trying to access the system. I don't care. ICMP, yeah, maybe, maybe not. So what happens now, as soon as I say OK, TraceWrangler reads that file, reads every frame, creates a conversation filter for every frame, and adds it to the list. Okay? So basically, it will create Wireshark filter syntax for me, at least for the display, for all the packets in there that I would otherwise have to use or create manually. So I use a trace file as a source for creating a filter set. And these are 52 filters. But it's only one file yet. So what I do now is, okay, add the other one. Now it's 93 filters. Okay? And what I can do now is simply go here and say, well, separate this for me, please. And then it will extract all the conversation from the original files into single files, but only if they had been matched by snort. Yeah? What I showed yesterday is if you don't have a filter, it will just pull every conversation out and write it in its own file. Now it will only write those that have been hit by a snort filter. And when I wrote this, I was like, yeah, that is kind of okay, but not good enough for me. So I'm not going to run this because it will just take away time. What I will show you is the much better thing that I'm going to do instead. So I close this thing again. I add a new task. And now I will add a filter again from file, but from a different file. I will use the alert log. And I can show you the alert log. This is what it looks like. It will tell you exactly what did Snort find. It thinks there's an SSH brute force tool at work. It knows the conversation. There's the IP addresses and the ports, and the IP address and the port. It even knows the sequence number where this was matched. So it's pinpointing a specific packet, just like I've seen in the extracted file. So I'm reading that file instead, which has much more information. And now there's a funny thing, because since Snort writes the name of the filter that matched into that alert file, I can pull that out as a filter label. So I can put a name to each conversation filter so that I know why was this filtered, which Snort filter was responsible for this one being pulled out. Okay, so I have 94 flow filters, and I have more metadata infos, because often you have multiple matches per conversation, so that can happen. And you can edit them if you want to. If you think they should be different, you can edit anything, or you can go in and say, well, if I have some conversation type or some type here that I don't care about, like this stuff, you can always just delete them, so they will not be added anymore. But I say, okay, go to the output thing, and now I can here add the filter label to the exported file name, which will lead to the export having the conversation names like source IP, destination IP, source port, destination port, and also the name of the filter that matched, which is quite nice. So I will run this, and we will see if TraceWrangler is nice today or if it is unhappy. So if I run this, we should get a new extracted subdirectory here. And now all the conversations show up one after one. And now I sit back and drink my coffee, because it's just pulling all the conversation out for me that I used to do by hand. And the interesting thing here is that TraceWrangler, by having scanned the big files when I added them to the file list, remember? It knows exactly where the first frame of each conversation is. It also knows exactly where the last frame of each conversation is. So it can discard writer objects as soon as it knows that the full flow has been written to disk. Yeah, and you can see that on the status page of TraceWrangler. I think it's still running because it isn't that fast. Here you can see how many active writers do I have. So how many files are open at the moment, and how many did I have at the highest count in parallel. So it's opening up writer objects whenever a new conversation is found, and it closes it as soon as it knows, oh, it's done. Yeah. So this will take a while, but when it's done, we will end up with a nice list of things here. And now I can maybe start with some of them already. What I do is I have the list on one side and Wireshark on the other. And that's, again, a reason for having multiple monitors. Yeah. So I have 3 right now because 4 don't fit. And I can just pull them over here. Yeah, so that way it's really fast and a good way to just find out what is happening. And what TraceWrangler also does, and that is something why the metadata information was interesting. Let's pull over a putty thing. TraceWrangler will also write a comment to that packet in which the Snort signature matched. So there should be a packet here somewhere where it matched. And I'm not sure, I probably have to go for frame.comment. Come on. Why doesn't it filter? There it is. So I can clear the filter again. So in the third packet, you can see TraceWrangler added the name of the signature that matched on that packet. So if I'm adding the comment as a column, I can really quickly see, okay, this is the conversation. Well, it was isolated by TraceWrangler already, but I can see instantly at which packet was the thing found, because very often if you have like a pattern that is just a couple of hex bytes, you're always wondering, what packet was it where it matched? I don't have to know, because TraceWrangler, while writing the frames to disk, sees, okay, this is the sequence number where that filter matched, and writes the comment about the filter into the packet comment. And that way, this is just a matter of dragging and dropping all the stuff on Wireshark and saying, okay, I don't care, I don't care, I don't care. Oh, this is something I need to look at. I don't care, I don't care. It's much faster than anything else. So this is how I do this now. And you can too, because TraceWrangler is free. You can download it. That version here, which is much better than all the other versions I've put up, is not on the web yet, because I'm still in the process of open sourcing it and getting there. But if you want it, you can get it from me, bring your USB stick, and I copy it over for you. Okay? So it should be done in the background now. Yeah, it's done. So we can see that I have a ton of extracted things here. And what I also could have done if I wanted to, and that's just maybe the last thing to show you, I could have gone into the output settings, and instead of having the filter label as the first part of the file name, I could have pulled that from there and just put it here. You can put any of the placeholders that are listed down below in any of the fields, and what will happen now is that if I run it again, I will get a subdirectory in the extracted directory with each filter name being one directory where all the conversations that are matched by the same filter will be written to. So in here I get now all the conversations for that filter. Simple way, building your output scheme by putting all the placeholders wherever you want, and then go through them really quickly. Yeah, so this is what I do to make my life easier. And I'm not sure if I have a slide left, but I think the last one is this one. So I think it's 5 o'clock, is it? Hey, I made it on time. Amazing. Thank you.